All right, guys, happy Monday. It is your last Monday of the school year. So I just want to take some time just to review kind of things what we did on Friday. We talked about the probabilities of any event happening have to be between 0 and 1. If I were to add up all the probabilities together, that sum would be 1. I added all of them together. Um, that the probability that an event does not occur is 1 minus the probability that it does occur. And if I have two disjointed events or mutually exclusive events, that means that they both happen. Both do not happen at exactly the same time. What I want to do is just to help you guys out, because I know some of you guys struggled with the assignment on Friday. I want to give you guys a chance to just kind of see what the answers were to the ed puzzle that you guys had on Friday. So I just want to work through these with you. I'm going to have some more for you, and then you're going to have an assignment on Google Classroom to do to help you guys review this. All right, so we talked about mutually exclusive events, and those are events that cannot happen at the same time. So if I want to find the probability of A or B happening, I'm just adding the probability of A plus the probability of B together. So this is the question. This is one of the first questions on that puzzle that you guys had. It says that a student athlete may participate in only one sport per season. In the spring, 15% of the athletes play baseball and 23% are on the track team. What is the probability of an athlete's either playing baseball or being on the track team? So we're trying to find the probability that they play baseball or track. Okay? Just looking at what we did on Friday, we talked about if they are mutually exclusive events, all we have to do is add the probability of A plus the probability of B, because both A and B cannot happen at the same time. So that's what we're going to do here. We're going to take the probability of baseball happening plus the probability of track happening, and then finding out what the overall probability of baseball or track happening. So it's a 15% chance that they play baseball, and it's a 23% chance that they do track. So if I add those two, I get 38%. So there's a 38% chance that they could do baseball or track. Okay. Now, we also looked at it. This is the second ed puzzle question that you guys had, in which I asked you guys to find the probability that it was blue, black, or red ships. So because we do not have the ability to have a blue, black, or red ship, any combination of those, what we're going to do is just find the probability that blue happens plus the probability that black happens plus the probability that red happens. As you guys do recall, there were 15 ships in our bag overall. Now, the number of blue ones was 3, the number of black ones was 6, and the number of red ones was 4. So if I add up all of those together, 3 plus 6 plus 4 is 13 out of 15, which if I just simplify that or find a decimal form for that, if I take 13 divided by 15, you guys should get it to be 86.6% or 87%. Okay. All right, so those were the first two problems on that puzzle that you guys had on that first video. Now we talked about after that when we have overlapping events. Okay, these are both A and B can happen at the same time. So what happens is we're taking the probability of A plus the probability of B and subtracting the probability of A and B. So we're looking at this scenario. This is the first number 3 on that puzzle that you guys had to do, in which we're trying to find the probability that red or blue card happened or a card less than 6 happening. So what we're doing is we're taking the probability that a red card happens plus the probability of a blue card happening. Now, is there any intersection between red or blue? Those are examples of mutually exclusive events. Okay, so there's no intersection between them. Now, we also have the probability that it's a card that is less than 6. Okay, is there any overlap between red, blue, and a card less than 6? Yes, there is some overlap between that. So we're going to subtract the intersection of red and blue, and then when they were less than 6. Okay, so how many cards are red? Looks like there's 10 of them. These are all the reds. Okay, So we have 10 out of 40. Now, how many blues are there? Once again, it looks like we have 10 out of 40. Okay. Now, we're going to change my color here just because I can. Let's choose black. Okay. All right. A card less than 6. So these are 1. These are 1s. These and these. And how many cards did I circle? It looks like I circled 20 of them. So I got 20 out of 40 cards are a card less than 6. Now, are there any cards that are circled twice? Well, it looks like 1, 2, 3, 4, 5 red, and also the same thing for blue, which means I have 10 cards that are counted twice. Okay, so I'm going to add those and then subtract the intersection between them, which means I get 30 out of 40, which is the same thing as 75%. Okay, so that's the third one on video 1 from Friday. This is the last one that you guys had on Friday too. All right, so what is the probability that it's red plus the probability that it's green plus the probability that it's even? Now, there's no intersection between red and green because we can't have a card that's both red and green. But there is some intersection between red, green, and even. So we're going to subtract that intersection of red, green, and even. Okay, so let's look at the red. How many reds do I have? Looks like I got 10 out of 40 are red. Now, how many greens do I have? Looks like I got 10 out of 40. Okay, so we're going to try to circle some evens here, huh? Okay. That's, that, 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 this, these. Okay, so how many cards did I underline? Looks like I underlined 40 of them. So, oh, no, there are 20 of them. Jeez, oh, Pete, Mr. All right, so it's 20 out of 40. All right, now, how many did I circle twice? Well, it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's subtract 10. If I look at all this, once again, it's going to be 30 out of 40, or a 75%. All right, now, that was that first video. So once again, just to kind of go through the first question that you guys had, is we'll try this, and you guys found out that would be 38%. That second one that you guys had on Ed Puzzle, you guys got it to be 87%. Then you guys got 75% for the third one, and then 75% for the last one. Now, on that oh no, I guess we got a couple other ones. I forgot about that. Now, what is the probability that the kitten is female or brown? So what is the probability that it's female or probability that's female or brown? Okay. So what we're going to do is, because there's some overlap, we're going to take the probability that it's female plus the probability that it's brown minus the probability that it's female and brown. All right, so how many cats do I have overall? I have 8. 8 of them. All right, now, how many are female? Well, it looks like I got some females here, and I got some females here. So I have 2, 3, so I got 5 of them. All right, now what are we looking at? We're looking at brown. All right, so we got some brown and brown here. All right, so I got 1 and I got 2, so I got 3 cats that are brown. Now, do I have any cats that I'm counting twice? Okay, and do I have any brown and female cats? And it looks like I have 2, so I'm subtracting the intersection. And what I get for that is I get 6 out of 8, which is 75%. All right, and then this last one. In a math class, 75% have visited the ocean and 50% have visited the mountains on vacation. If 45 have visited both the ocean and the mountains before, what is the probability that are randomly selected have visited the ocean or mountains? So probability that it's ocean or mountains is going to be the same thing that the probability that it's ocean plus the probability that it's mountains minus the intersection of the two. All right, so ocean. Well, 75% have visited the ocean. The mountains, that's 50%. And then what is the intersection between the two? That's 45. So if I look at all that and simplify it, it looks like I get 80%. All right, so that is the end of that first video. Then you guys had a second one in which you guys were looking at a table of values and just trying to find the probability that way. It was a grocery question. So in this case, a grocery store employee employs cashiers, stock clerks, and deli personnel. The distribution of employees according to marital status is shown. I found the totals for you guys just to help you guys out. I have 13 cashiers in total, 27 stock clerks in total, 5 deli, 23 that are married, 22 that are not married. And if I add up this way, I get 45. If I add down, I get 45. All right. So what is the probability that the employee is a stock clerk or married? Stock clerk or married. So we're going to take the probability that it's a stock clerk plus the probability that it's married minus the intersection of them. All right, so stock clerks. How many stock clerks do I have? Looks like I have 27. So I've got 27 out of 45 that are stock clerks. And then married. Now, if I circle this column right, this row right here, looks like I have 23 in whole, 23 in overall. Now, if I were to add those two, you would see that it's more than 100%. So it can't happen. It can't be more than 100. You have to subtract the overlap, which is 12. There are 12 people that are counted twice. So if I look at that, 27 plus 23 is 50 minus 12 is 38 out of 45. If I look at 38 over 45, that is 84.4%. Okay. Got two more for you guys just to go over, and then you guys have a couple to practice on Edpuzzle and then worksheet to try to do on Classroom. All right, so B, probability that's not married. Well, we're just looking at this row here. Those are all your not marrieds. So it's 22 out of 45, which is 49%. And for the most part, you guys did okay with that one. This is the last one, and this is the last one a lot of you guys struggle with. All right, so for probability that it's a cashier or not married, we're going to take the probability that it's a cashier plus the probability that it's not married minus the intersection between them. All right, so cashiers are right here. How many cashiers do I have? 13 out of 45 are cashiers. Not married. Looks like I got 22 out of 45 that are not married. Minus, how many are counted twice? That's 5 out of 45. If I add up all that together, I'm going to get 30 out of 45. That's going to be 66%. 67-ish percent. So here's what I'm asking you guys to do. I'm going to ask you guys to try a couple on this, on Edpuzzle, and then try the Google Classroom design. Have a great day.